welcome back everybody here in Hall 6. Now, since we've heard from the future champions of cybersecurity, we're going to transition to one of the grandmasters of the industry now. I need to read this off, it's just too much. He's a 4-time Microsoft Most Valued Professional, a CNCF ambassador, by choice an ex-HashiCorp ambassador. I was told to emphasize the ex. His LinkedIn profile says additional 43 licenses and certifications. He's a maintainer of Open GitOps. He's a fellow community organizer, and I'm especially happy about that one, co-chair of the CNCF Tech App Delivery. Give me a hand for Roberth Strand.
All right. Hello, everyone. It's great to be here. I only been in this great city once before. I ended up having COVID after that, so fingers crossed this will be better. So it's going to be a little bit funny for me going after the young crowd with all the cool tech, because now I'm kind of going to step a little bit back. This presentation, I got 3 slides. I have no clue what this presentation is. The idea was to do like I said, like a development cycle speedrun from having nothing to having everything in place. But I only got 30 minutes. So let's see how far we get. Yeah, let's just, like mentioned before, I usually have my own slide deck with like a nice presentation stuff. So since I'm using this one, I just put all the titles in. I hope that is fine. I primarily work in the Tag App Delivery these days. So done a lot of work with the Platforms Working Group and so on and so forth. Been doing this for a while, speaking at everything from KubeCon to local meetups everywhere. More importantly, at least for me, is that I'm the founder and chair of Cloud Native Norway, and we're organizing events. So if anyone wants to come to Oslo in January, bring good clothing, I guess. Might be like minus 25 degrees, but it's fine. We'll be inside most of the time. Around, I think it's 23rd of January, we'll have Cloud Native Day Oslo. So look out for that. So, as I mentioned, I don't have, I have a very, limited set of things I can do in 30 minutes. So that was my slide deck. All right. So let's write code. First of all, I just want to ask, let's just do that. If I can see you. Show of hands, who here is a developer? Seems like most of the people. Well, what is a developer? Who here is on the operations side? Is it platform engineer, cloud engineer, DevOps, not engineer, because that's stupid. All right, cool. Who here works with Kubernetes on the daily? Oh yeah, well, it makes sense at this conference. Who here is a total beginner to Kubernetes? All right, so I'm going to try to adjust accordingly, but for some of you, this might be a little bit basic. At the same time, I hope you find some use for it. Hopefully, this will help you when you're trying to teach others about Kubernetes. So, like I said, we don't have any slides, so let's jump into code. Does anyone see that, or do I need to change my... Is it dark? No? Okay. So the idea here is to take what essentially would have been an empty Git repository and then get stuff into Kubernetes. The way that this works right now, because I only have 30 minutes, I can't really do that, so I cheated a little bit. So I've created an application. This is written in Go. This is Fiber, what you see on the right side. Your right is there. And basically, we're just spinning up a new instance of Fiber. We have a public folder, static folder called public, where I'm going to have my awesome web app. It's not really that awesome. It's an HTML website. That is as good as I can be at front end. I'm sorry, that's not my thing. Adding an API endpoint, because later on when I do this again, I will have more stuff related to that. Let's just skip over that for now. And then I have a very funny named endpoint called health, because that's a thing in Kubernetes. You kind of have weird endpoints instead of just calling it, I don't know, ping or something. So this is something we're going to use afterwards when we start doing the deployment, right? We need something where we can check if stuff is working. This is just hosted on a server port, and I'm just getting that from an environment variable. Let's take a look at the Docker file for this. So multi-stage stuff. To be quite honest, I just copied this from an old project. So don't look too much into the code here. It might be up to date, it might not. But basically, we're building this application using the Golang container for build stage. We're just copying in some stuff, making sure we got all the packages that we need. We're copying over our many Go files, the main.go file, and then we're building it. And then we have the stage which will create the container we're actually going to use. We're doing some typical stuff like putting on labels. We're doing some installing stuff that I actually don't really need in this case, but again, just copy this from somewhere else. Setting the work directory, setting the user, and then from the build stage, we're copying over our new binary web app, and we're copying over again our wonderful front end. Setting the environment server port to environment variable server port to 9020. Why 9020? That's the zip code of the town that I'm from. So I just keep on using that because usually people don't use that. And then we expose that and set the entry point to be that web app. All right, so we do that. We created that. We put that into GitHub. We have a build stage, et cetera, et cetera. That container gets built successfully. At least at one point, put into a container registry, and that's where we're at right now, right? Hopefully, if I had more time, I would have also gone into like monitoring and stuff like that from like a developer standpoint. Look up OpenTelemetry, right? Start using that. So, all right. The main idea here is to kind of show that it is relatively easy to get started deploying stuff into Kubernetes, because every time I talk to someone who hasn't started that journey, and often also people that have started that journey, it's like Kubernetes is so complicated. And sure, it is complicated, but then again, everything that we do is complicated at some point or another, and then you learn it and kind of go like, yeah, that's not really that hard. So Kubernetes in itself is not really that hard as long as you know kind of like the basics, building blocks. And the main thing that you as a person that are deploying stuff into Kubernetes need to know is the resource deployment, the deployment resource. There's many ways to get a deployment manifest created. I have an extension in Visual Studio Code, so if I just write deploy and press enter, I got it. I'm done. More or less. Obviously, I need now to fill in the blanks, but at least now I have everything that I need, right? So if I first of all change the name and the label and the label and the name to something, we are pretty far along the way already. One thing to note here is that there's no namespace set up. This is, I think, very important to talk about. Don't put stuff into default namespace. Don't do it. You need to take a conscious effort into like deciding where things are supposed to be. And there are no rules. There's no I hate the word best practice because what does that mean? But in general, people try to create a namespace per application. And everything that's related to that particular application happens to be in that namespace. So let's just say that we want it into the namespace, not default. Demo, thank you. Other things to take a look at here and kind of understand is that we have some stuff here called selectors, match label, and then we have template, and that also sets a label. So the template is for the pods themselves to set the labels, and then the selector is for the replica set which the deployment resource creates. That makes sure that all the pods that come up, belong to certain replica sets and so on and so forth. So it knows which one to go for. Funny thing, if you need to have the match labels here, this needs to match with whatever's down here, obviously, because or else it wouldn't match and work. So if you add something up here and then try to deploy it, kubectl is basically going to go, that can't be. Like you can't match on more labels than the deployment that you're trying to do. However, you can add more labels to your pods. So if you need to add extra information, you can still put that in here, and that will work. Just not the other way around, because or else the deployment and then replica set wouldn't know how to connect with all these things. We're not going to do that. We're going to keep this very simple. This is kind of too simple, but whatever. We need to have an image. I know that this is not in that one. That is in my, it's called exactly what the repo is called. And let's do latest. Should you do latest? No? So one of the things that I think is cool with what Kubernetes have become now, again, there's a lot of default decisions going on under the hood that you might not know about. For instance, what I used to say is, don't pick latest, because when is it the latest? It's when stuff gets pulled, right? And you can set the deployment to be pull the new version of the container every single time. It's called image pull policy. So you can say image pull policy, always pull a container down. If you set this latest, the first thought that I had was you would get the latest at that point and then never change again. But actually, the image pull policy is automatically set to always if you use latest, unless you specify something else. So you kind of have to go out of your way to kind of screw that up, which some people do. But obviously the best scenario is to have specific tags, because specific tags is easier to understand. If something goes wrong, you know which version is running in your cluster without checking, because the code says so. You can more control, like upgrade, etc., etc., etc. One other thing that this extension did, it put in these resource limits in here, which in itself is a good idea. I think it's kind of funny that resources is something that is not required. So if I remove this, we're going to get squiggly stuff, but it's going to be yellow squiggly stuff, which means it's a warning, right? If I hold over this, it's going to say, does not have resource limits. This could starve other processes, which is correct. So it automatically, it's not like it's an optional field, but in the same way that the namespace is an optional field, you should always have this in there, right? It makes more sense than not to have it, which is one of the reasons why when you're writing YAML, because YAML can get funky quick, right? There's all these like indents and stuff going on, and I don't remember half the time where I'm supposed to put stuff, because ADHD and there's a lot of text, and I kind of just go like, yeah, sure, there, and hope everything works. Putting these things in there is great, that these extensions kind of do that. I think it's kind of funny that it doesn't put in namespace, which everyone should use. So I don't know, conscious decision there from someone, I guess. Anyway, resources, you have limits and you have requests. In this case, it was only limits that got added. And why is that? Because if you don't set resource request and set in only limits, the request will be the same as the limits. So this would kind of be just like hard pinpoint. This is the amount of resources that we both request, and it's as much as we can use. Is it a viable strategy just doing that, or versus being very specific? Like there's it depends. Then the consultancy answer, it depends. Let's have a meeting for 2 hours about it. So in my mind, at least, setting only the limits is a great way of just like getting stuff done. I almost swear it. I'm from the north of Norway, so I swear a lot. But getting stuff done is great. You just set this, and then the resource-wise, everything will be set. So at least put in the resource limits. And then there's an entire debacle about like one of the specifics here about CPU usage and so on and so forth. And I know that was like a thing on Twitter, back when it was called Twitter at least, about if you should set it or not. Not going to get into that. Last thing here we need is the port, 9020. And we basically have a deployment. But we do have a deployment that's in a namespace that doesn't exist. I could just do kubectl create namespace and demo, which is fine. I would prefer to have everything in code as much as possible. So let's add it up here. And so you do the three dashes to indicate that these are separate things. This is how YAML works. Don't ask me why it's like that. And while deployment, I could just write deploy and get everything served. For some reason, that doesn't happen with something like namespace, which kind of sucks because, again, I don't want to write YAML. And I tried using GitHub Copilot to just like fill in the blanks. So I started by like kind namespace, and then I got random stuff and wrong information in it, and then it didn't work, and I got pissed. So what I found out, if we do like a comment and say, well, not that, but good idea. Create a namespace called demo for this deployment. And then I'll do this. Well, that really didn't help. Again, AI, we're so much more efficient. So if I do this, I think that's correct. All right, sure. Let's remove this because that was just silly. All right. So we got two of the things that we want. What we're missing here, since this is a web application, how am I doing on time? Still good? All right, cool. Now this is a web application. Let's actually just apply, live a little. Well, the code works. So we got our namespace here. And if you haven't seen that tool before, k8s or k9s or whatever you want to call it, it is fantastic. It is great. Everyone should use it. Basically, instead of, I see a lot of people are just writing all these kubectl commands and so on and so forth, which is fine. It works, and if you remember all those things, that's great. And even though this is a tool that's very helpful to at least demo stuff for me, because I don't have to write these commands and get a little bit of text back. I can actually see stuff. So here we see all our namespaces in my cluster. See, I got my demo one. Press enter to go in. There's my pod that the deployment created. If we say deploy or deployment, we'll see the demo deployment, ready 1 out of 1, up to date 1, how old it is, etc., etc. I can press D to describe, get all the information I ever would want out of this, to the point where I can just press L to do logging, right? So I can just output the logs directly into my CLI. It's great. This also makes it easier for beginners to get into these concepts, because if you sit there, you start doing like kubectl create deployments and so on and so forth, and then it's like, okay, do a log. So, all right, how does that work? It doesn't really make sense unless you know how to do it. So being able to just do like a click L on something and get the logs, great. So, but we have a web application. We could potentially check it out, but at the same time, we have, at the moment, 1 pod running with this web application in it. However, what if we scale this up? What if it's 100 pods, right? We can't go into singular pods and look at the web service running there. So what we want is what's called a service. And luckily, this one exists. I can just do that. And same deal, we have our metadata for the service itself and the selector for the label. That is going to be both demo, because, no imagination. And we need to put it into namespace, the correct namespace. The port and the target port, both going to be 1920, because that's a cool number, keep on using. And if we now do a k-apply on that, we now have a service. It's already created, it has a cluster IP, so internally it has an IP that works. It doesn't have an external IP. This is one of the great things about Kubernetes, is how modular it is. So if this was running on Azure or Google Cloud and so on and so forth, you could just say, I want the service to have a load balancer, and the cloud would just make it. And then you have an entry point. It's magic. like literally. But at the moment we only have this. Let's see if I do again k9s. This is not a k9s demo, but it kind of becomes that. If I do Shift F, I get automatically this port forwarding menu. Yeah? So it says the port, local address, etc. This is all great. I'll do that. And if I do this, it's my website. I've been doing websites since 2003. I never improved this. Yeah, it shows, right? This is classic, right? So, and CSS was created by a Norwegian guy. So, I need to show him my work. /API, I get hello world, which is great, right? And then we have our health, which says okay, right? That's okay. Cool. So I'm almost at the end of what I can do in 30 minutes. Well, on this topic at least. Well, no one got it? Okay, great. If I do deployment and look at the logs, I see that, stuff happened, which is great. I don't have the room. I just started using, oh no, okay, don't touch stuff. I started using a window tiling mode on a thing on Mac, and I still can't understand how everything works. So I keep on doing mistakes. So, don't touch it. But trust me, there's more information there. It says what endpoints we were hitting and things like that. They're really cool. Right. So the last thing that I think a lot of people not ignore, but probably don't know about is the probes. And for those who work with this on a daily basis, of course the probes. But every time I help a team of developers or someone that usually don't work with this, every time I look at their deployment, it usually lacks probes. So there's two types of probes. There's the readiness probe and the liveness probe. Which one does what? Readiness probe is a indicator of that stuff is ready. So for instance, I have a web, yeah, correct? All right, cool. If I have a web server, I would like it to be ready before I start sending traffic, because you might have stuff that's happening at the beginning, or you need to check something, and you need to make sure that when people start hitting that server, that there's stuff to serve. So that is the readiness probe. All right, cool. So for readiness probe, I'm going to use an HTTP GET probe. So it's gonna basically hit the same thing as a user would do, which is the web server. So I can set the path, health, again, whoever figured that out, and on port 9020. So if I do this now, first of all, if I go to pod, you'll see that I'm now destroying a pod, because you can't kind of just update liveness and readiness probes. You kind of need that from the get-go. So now we have a new pod. And that new pod, if I go the logs, you can see we're already hitting the health endpoint. So by default, it will wait a little bit before starting hitting it. It does this every 10 seconds by default, I think. There's actually two settings here. There's a delay something to delay, when the probe should start hitting, and then it's the interval of pings. By default, like I said, the interlay one is 10 seconds. The default on the delay is actually 0 seconds, which makes no sense, because if stuff, you kind of need to breathe a little bit. If it checks straight away if everything is all right, then probably stuff crashes and burn. But there's a logic here, apparently. So the delay one is 0 second, but if the interval one is a higher number, that overrides the delay. Because that makes sense, I guess, somehow. So if you put in nothing, it will be 10 seconds delay before it starts checking, and then it checks every 10 seconds. What you can do is you can set this to like, check every 15 seconds, and then it will wait for 15 seconds and then start doing it. So that kind of makes sense. If you then need to have more breathing room before you start checking, then you could set the, wait a little bit before we start getting going. So these are the things that I kind of have to deep dive into sometimes, and it's kind of interesting that there's all these weird defaults everywhere, right? So readiness probe, again, make sure everything is ready before we start sending in traffic. And then we have liveness probe, which, at the moment, I'm just gonna do exactly the same. I wish this AI thing could put in stuff before I got there. Thank you. So I don't have to write everything. Could do it exactly the same. Is this a good thing to do? So the liveness probe is literally Kubernetes checking if everything is alive. Like it has stopped, has the container stopped? Did it explode? Did it, something happen that kind of, did you get hacked and they managed to stop your process and stuff like that? And the idea here is that if you can't get that liveness probe hit, you would then restart the container so you can get up again. And then obviously if it starts like rebooting all the damn time, you need to fix your shit. But at the moment, I'll just put in, let's get out the logs, save, and just do this while we're at it. Get it deployed again, just to prove that it works, right? So it's running. So now we'll start seeing twice the amount of probing on health. Is it a good idea to just put it on the same endpoint? Probably not. There's probably someone that has some sort of opinion on this. Again, I'm just doing a demo. So this works. There's other things you can do. You could, for instance, on the readiness probe, a good idea would be to have, or even liveness probe, have some sort of script or startup script. So part of the startup that you write a certain file to say everything's okay, and then you can check that file, for instance. So that's one other probe you can do. You can also do gRPC and et cetera, et cetera. So you got something for all girls and boys. Best practices here, I would say just like get stuff probed. That's a good start, because all of these things we could live without. We don't necessarily need to have the resource limits. We don't necessarily need to have these probes. If we removed all this and did a kubectl apply on this, it will work. The problem is we're making it really hard for Kubernetes to figure out what's going on, right? If you don't set like how much resources you should have on a pod or set of containers, Kubernetes kind of just have to put your pod somewhere and hope that everything's all right, right? That's not really great. So you're helping Kubernetes by adding, the resource requests that you have. I always thought that the limits then also was kind of like an upper limit, so it kind of look at that, but apparently it doesn't. It just looks at a resource request, puts it somewhere. If then the limits are like way over and everyone wants go all the way to the limit, you're going to crash your node. So something to consider, and another plus or another feather in the cap of setting resources to limits, and that's it, right? That would make everything much smoother. Same with readiness and liveness probe. This is basically just a way for you to make sure that Kubernetes knows what's going on, right? It's just like making these. There's a lot of logic behind Kubernetes that is very efficient and great, but just leaving it totally for it's like we're not there yet. We don't have systems. We just put stuff in and then everything works. AI is apparently that, but I don't know. Like most of the times stuff goes bad when I try to do AI. So it's probably just me, but a little bit AI's fault, I guess. All right. Like I said, the next thing on the agenda here was get metrics and logging and tracing. Again, can't really do a demo of that, but it's relatively easy with the OpenTelemetry project from the CNCF. One other thing that I would like to show is obviously, I said like Open GitOps maintainer. I'm very pro GitOps, weirdly enough. And having that entire cycle with the continuous deployment scenario using a GitOps tool, that would also be kind of like the next step here. So while we have not that long, many minutes left, I guess, yeah, probably. First of all, thank you for listening. Secondly, any feedback to this as like an introductory thing would be great. If there's anything that kind of went missing, so you who are totally new, please, talk to me afterwards and let me know what you think. I'm going to do this presentation again next week with more time towards a crowd that has no idea about Kubernetes at all. So I'm going to do a little bit more explaining then on concept as like replica sets and stuff like that. All right. I think that's what I had time for.
Perfect. Great introduction. If you have any further questions, please hit up Robert at the coffee booth outside. We'll be back in 10 minutes here. Yeah. See you.